Today we are going to solve a numerical question from frictional chapter. It is going to be a very short video. So without wasting any time, let's just read the question first. Okay. One second. Okay. What it is saying? It is saying a block of mass 2 kg rests on a rough inclined surface, making an angle 30 degree with the horizontal. And what we have to find out? We have to find out the maximum force of friction, the maximum force of friction. Okay. So what at first what is given? A block is placed on a inclined plane, inclined surface. So this is the horizontal surface, and this is the horizontal this is the horizontal surface, and this is the inclined plane, inclined surface. Uh, though it is less than 30 degree, but okay, let us imagine this is this theta equals to 30 degree. Okay, this 30 degree angle, and this is a inclined surface, rough inclined surface, making a 30 degree angle with the horizontal surface, and a block is placed above, placed on this rough inclined surface. Now what is given? Mass of block is given as 4 kg. Mass of block is given as 4 kg. The mass, okay, let me write in a bigger font. 4 kg. Mass of block is 4 kg. Okay, and theta, angle theta, the angle of inclination is 30 degree, which I have written already, and we have to find out maximum frictional force, F max equals to how much. Okay. Now how many forces are acting on this block? There is a normal force. Before normal force, let me write down the weight first. Okay, this is the weight. This is the weight of the weight of the block will be acting perpendicular to the horizontal surface, isn't it? It is going to act perpendicular to the horizontal surface, so in this way. So mg, weight equals to mg. G is the acceleration due to gravity. Okay, acceleration due to gravitation. Now, are you able to see? Okay. So mass of m, here we are taking g as 10 to the power, approximately 10 to the power m, 10 meter per second square. We can write it at 9.81 or 9.8, but we are for ease of calculation, we are taking it as 10 to the 10 meter per second square. So it is going to be 4 kg times 10 kg meter per second square, or you can directly write Newton. You have to remember that kg meter per second square is equal to Newton. So 40 Newton is acting on this. 40 Newton is the weight of this block. Now there will be a particular component of the weight of the block acting across the normal, or the normal, as a normal force, or the perpendicular, acting perpendicular to the surface on which the block is placed. What is normal force? What is normal force? Normal force is the force acting exactly perpendicular to the surface on which the block is placed. So normal force will be equals to mg cos theta. It is going to be cos component. Why? This is theta. This is going to be 90 minus theta. This is 90. This is 90. So this is theta. This is 90. This is 90 minus theta. Total summation of this the angles of a triangle is 180 degrees. So this is 90. 180 minus 90 is 90. 90, and this is theta. 90 minus theta. So this is going to be theta. This is going to be also going to be theta. So the cos component will be acting across the normal force. So mg cos theta. Now mg cos theta, what is n equals to mg cos theta? Equal to 4 times 10 times cos 30 degree. Cos 30 degree. So 40 cos 30 degree. It is the normal force. So 40 times cos 30 equals to 34.64, is 34.64. Now the value of mu is also given as 0.4. So the coefficient of friction between the inclined surface and the block is mu equals to 0.4. So maximum frictional force, we know that maximum frictional force is always mu times n. Mu times n. Mu we know that point, it is given as 0.4, and n, which is the normal force. Normal force is given as we have determined it to be 34.64 Newton. So 34.64 Newton. Okay. So 0.4 times 34.64 Newton. So 0.4 times 34.64 Newton is 13.856. So 13.85 Newton is the maximum frictional force. Hope you have understood everything, and hope you like it. If you like it, please don't forget to like, share, and subscribe this video. Thank you.